Okay, so in the voltage, so by the way, that when you are sensing the output voltage, we call it voltage mode hysteretic, because we are looking at the output. And we saw the issue was that you need a large ESR. Basically, the RC time constant should be much larger. The RC time constant at the output cap should be much large. So, either you have to increase the capacitor or increase the resistors to make resistor to make the output ripple in phase with the inductor current. Okay. So, then the drawback is that either you need a large capacitor, or if you let us say try to reduce the ESR, and if you are using a smaller cap, then your ESR will be much larger, and then in that case basically your ripple component will increase actually. So, then we look for current mode hysteretic. So, ripple we want in phase with inductor current, then why do not we just sense the current and generate the ripple out of that rather than relying on the output voltage, because we know output voltage is 90° out of phase from the ripple inductor ripple current. So, let us draw the same circuit again, and this is C out, this is L. This is your comparator, minus plus, it is hysteretic comparators. Okay. So, this was our voltage mode. Now, instead of feeding this, we want to feed the inductor current. So, I will just remove this, which means I need to sense this current. So, how can I sense this current?
Current mirrors.
Current mirrors? Where is the current mirror?
You can convert the voltage to current.
How will you convert it?
Current to LV what means current mode control. Current to voltage.
But in the current mode, you remember we have two feedbacks. One is the current, other is the voltage. So, the only current will not help. How will you regulate the output if you do not have a feedback from the output voltage? So, let us say under no load condition, what is this? D times VDD under no load condition, or RDCR is close to 0. So, two conditions, if your inductor RDCR, then drop will be less, then you can assume this, or your load is 0, so IR drop is 0. So, I know that this inductor is integrating the voltage and converting into current, because if you write the equation for current, inductor current, it will be integral of 1 over L VL into dt. Okay. So, we want to build the same thing, replicate the same thing, and we are looking for voltage, not the current in the feedback. And so, what if I do this? Let us say this is, let me give RC CC. What will be the, so let us say RC time constant is very large. What will be the average voltage at this node?
Average voltage is same as the average of.
It's same, Ultimately both are low pass filter. LC is low pass filter, this RC, the difference is that is second order, this is first order. So, your output should be same. So, take this and connect here. So, what would happen? This will be something like this, correct, provided that RC time constant RC Cc is much larger than TSW, because we are looking for a integration, and this first order low pass filter will work like integrator if time constant is very large. Otherwise, you will get a non-linearity due to exponential relationship. Okay. And now, if I call it, let us say Vc, so Vc is nothing but d times Vdd. So, you will get the regulation. What about the transient response? And other thing is good thing, now you are not depending on output ripple. You can make it so output, so the hysteretic window we were keeping is based on the output ripple required. Now, I can keep this 50 millivolt or 100 millivolt, it will not affect your output, correct, because it is not going to affect your output ripple. Output ripple will always depend on switching frequency and this LC filter. So, if I want to write the expression for frequency, how will I write? So, let us say I take this filter, I can assume this as a ground, which is V out, AC ground. I am looking for a small signal. This is V out, or let me write T times VDD to avoid a confusion that they are shorted. They are not shorted. It is actually Vc. So, Vc equal to, and Vc is same as V out under no loss condition. Okay. This is nothing but VSW, which is getting this. So, if this I call it IR, so what is the charging current? Charging current, if RC time constant RC Cc is much, then you can assume Vc as a DC, because VSW is a large signal and Vc is a small signal, even if you consider that 50 millivolt or ripple, because VDD did let us say 1.8 volt that. So, you can always assume that the current in the resistor will only be affected by VSW, okay, not due to the change in Vc, because that is small signal change. So, it is nothing but, if I call it IR equal to VDD minus Vc over R during on time. During T on, and we know Vc is like this. So, if I call it VR, so what is VR? What will be the VR? Sorry, RC. How come? Is charging the capacitor, huh? So, C dV by dt, correct, and this is nothing but Cc. So, what is dV here? We are limiting between hysteretic window. So, dV is nothing but delta Vh. What is dt? D times TSW, T on. Now, you will substitute those equations and I can find from there. So, IR is nothing but VDD. So, this implies VDD minus Vc is nothing but D times VDD over RC equal to Cc delta Vh over D times TSW, correct? So, just leave 1 by TSW. So, 1 by TSW equal to VDD into 1 minus D into D over RCCC equal to FSW, correct? There is a one more component, delta VH. Okay, what was the equation for inductor? So, let us say I want to write in terms of current. Okay. So, what is delta IL? Inductor current VDD 1 minus D over L into TSW. This is what you have. So, what will be the FSW? VDD 1 minus D into D over L delta IL, okay, which means delta IL is replaced with delta VH, that current, and RC CC is representing, or sorry, L is represented by RC CC, okay. So, whatever L acts as a, whatever the function of L in a current, the same function is RC in voltage, and whatever delta IL, the ripple you had now, that ripple is converted to delta VH. Now, in voltage mode, hysteretic, your FSW was VDD 1 minus D into D over L delta IL into, this is what you had, So, that is the only difference between the two. So, what is the advantage of current mode here? What do you see? So, if I want to talk about voltage mode, hysteretic and current mode. So, what was the first drawback of voltage mode we talked about? Large ESR. So, number 1, large RESR. Here it is not depending on RESR, so can be 0 actually here, it will still work. What was the second thing? Frequency was depending on almost everything, L, RESR, V in, V out. So, what is the common here? So, VDD and D, VDD, D and delta VH, these three terms are common, okay. But so here L and RESR is the extra term which may vary. So, frequency is depending on L and RESR. Here L is not coming, so it will only depend on RCCC, and think about RCCC is on chip. So, the tolerances on chip resistors and capacitor is less compared to your off chip. So by the way, this will get reflected to large output ripple, which means small output ripple. Frequency is ln RS. What else? What about the noise sensitivity? So delta VH is small, so which means if I call VP sensitive to noise, delta VH could be large, so less sensitive to noise. Okay. So everything looks good. Now, so far we have considered no load condition. What would happen when the load comes? So let's take the same thing. What is V out? What is V out under load condition? D times VDD minus. What is VC? What is VC under load condition? It will be same, huh? There is no current flowing through in that resistor, huh? Which means, and what are we regulating? V out or VC here? Huh? We are not regulating V out, huh, in this case. We are regulating VC, huh? Since feedback is from VC, not V out, so there will be what is that error? V error equal to I load into not RL, it's RDCR. RDCR. which means in order to make this error 0, your load should be 0 or RDCR should be 0. If RDCR is not very significant, or let us say the value you have and the load current you have IR drop keeps you within your accuracy limit, then you can live with it, otherwise it will not work. Okay, so how do we fix this? How can I fix this?
Somehow we can shift the ground level of
Ground level of what? How ground level will affect? Ground level of what?
C naught. If you change the
C naught?
no, instead of CC, if we somehow like there if we have something like I naught RDCR.
Yes, so but how do you know RDCR? Do you know RDCR?
Difference voltage between this DC and V out.
Yeah, if you take the difference, so what is the difference between VC and V out?
I know it will be
Okay, if you take that difference and adjust your Vref accordingly, then this will work. Okay, so V error should be added to Vref, correct? So, if I make Vref plus V error, then output error will be 0. And what is V error? V error is nothing Vc minus V out. So, this is the one way. I mean, you take the difference and add into that. What else can we do? I mean, which means you need a subtractor actually, and it has to be DC. So, you have to subtract and then filter it out to clean all the ripple, because they will have ripple. This guy VC will have 50 millivolt peak to peak ripple, the other guy may have 10 millivolt or so peak to peak. So, output won't be looking like a perfect DC. So, you need a huge filtering here which will increase your RC. So, what else can we do? So, instead of doing that, why don't I just take VC and V out, or not take the VC V out. So, I want to keep my average value of V out to be same as Vref. Okay. If I take this, if this is my, sorry, this is V out and this is Vref, and integrate the error and make it CTRL. Okay. So, you have another voltage feedback which is very slow, okay, and this VCTRL, what it will do? Control Vref, correct. Vref means whatever the extra component you want to add. So, this integrator will always force your Vref in such a way that your output is regulated to Vref. So, you need to take here from V out, add an integrator and control the Vref. So, it will be something like this, minus plus Vc Vref. Now this guy will be controlled by this. We call it integral. Correct. So this input to this comparator will settle automatically to the, I mean this integrator will force to a value for which V out becomes equal to Vref. But this has to be very slow. So this is another way to fix that. What could be any, I mean is there any other way? I mean if I do not want to use integrator, but what about the transient response of this current mode hysteretic converter? Hmm? Yeah, Vc won't change. No, it will change. So you have a capacitor connected between V out and Vc, the Cc cap. So any high frequency change will get reflected into Vc. Okay, but it will depend upon the that RC value, how much coupling it gets from V out to Vc, and then the frequency of the transient basically. If it is a very sharp, then that will basically get reflected because capacitor will act as a short for sharp changes. But if you let us say transient, I mean your output capacitor will always make your transient looking like a slow, it will smoothen out that. So you won't get the, I mean same undershoot or overshoot reflected at Vc. So it will respond to transient, but not as good as voltage mode. And other thing is, I am trying to keep this delta Vh large here due to noise reasons. So my output has to wait until that time before your comparator trips. Okay. So this large Vh window degrades the transient response. Regulation can be done with the integrator, but transient cannot be improved. So is there any other way like I can improve the regulation and transient both? So transient is slow because no direct feedback from V out. To the comparator. So now let us copy this again. Let us remove this. Okay. So I am interested in the ripple as such. Why don't I just simply extract the ripple and leave the DC? I can do that, How can I do? I just need to add one more capacitor. Let us say I call it CR. And where do I want the DC of this feedback? V out. Take this, add a resistor. Let us say I call it RF. Now this will go back to Vref. So if I call it Vf, yeah, let's call it Vf. So this was your Vc. And this guy was D times VDD. What will be the average voltage of this? V out. Okay, and this makes it, I mean both of them, like this is also a hybrid voltage and current mode, and this is also a hybrid voltage and current mode. In both the cases you are taking the feedback, but the difference is in one case you have an integrator, in this case you do not require integrator. So, the transient will be better and it will be only, so you have a RF, so if you look at a RF and CR, from this path you have a low pass filtering. Okay. So, you have to choose the value of RF and CR in such a way that it does not slow down your VF, and when you get a transient at the V out.